All right, so let's continue with some of these more complex ones. If we look at example G, we see negative 2, a to the negative third power, b to the negative second power. So what you got to remember about exponents is the exponent is only attached to the term that's closest to it unless there's parentheses around it. Okay, so for example, if you look at letter G, the negative 3 exponent is really only attached to this a. Okay, it is not attached to the negative 2 in any capacity. If we look at the negative 2 exponent, this guy is only attached to the b. Okay, so when we're moving our terms, we got to make sure we're only moving the things that the exponent is actually attached to. So when we're pulling this thing apart, the first term we see here is negative 2. Negative 2 is not being raised to the negative third power. It's just plain old negative 2, so it's going to stay where it's at. It's going to stay on top in this case. Okay, but because a is being raised to the negative third power, to make it a positive exponent, it's got to move to the denominator. And once you move it to the denominator, it becomes a positive exponent, a to the third power. And then b is being raised to the negative second power. Once you move it, it becomes positive. It should become b squared in the denominator. And this right here is in simplest form. Okay, same sort of principle for letter H. Okay, ask yourself every time, what is being raised to what power? The first thing I see here is 14 to the 0 power. Okay, 14 to the 0 power is the exact same thing as just plain old 1. Okay, I can write 1 if I want, but it's 1 times x, y to the negative third. Okay, ask yourself again, what is being raised to the negative third power? In this case, there's no sort of parentheses or anything. The only thing that's being raised to the negative third power is the y. So the only thing that moves is going to be the y. Everything else stays where it's at. So my numerator is just 1x, which is plain x. And my denominator, after you move the y, it should become y to the third power. Y becomes, or the exponent becomes positive after you move it. Okay, looking at example I see n to the negative first power over w to the second power. So first of all, check. Do you have any negative exponents? Yes, you do. N is being raised to the negative first power. The way we get rid of it, the way we get rid of the negative exponent is by moving it to the denominator. Okay. Once it moves to the denominator, it's going to become positive. It's going to become a positive exponent, just plain old n to the first power, or just n. But in my denominator, I had w squared. Okay, that's a positive exponent. I don't have to do anything with it. It's fine where it's at right now, so it just stays in the denominator, w squared. But we have nothing left on top, and if nothing's left on top, it's not 0 on top. It's equal to 1 on top. 1 over nw squared. Looking at example J, 1 over xz to the negative first power. So we see a negative exponent. We know it's not in simplest form. Only the z is being raised to the negative first power. So only the z has to move. Because it starts in the denominator, I have to move it up to the numerator. Once it moves up to the numerator, it becomes positive. Positive 1 as the exponent. Z times 1 is the same thing as z, which is plain old z over x. X stays because it's not being raised to the negative first power. Okay, a lot of pieces going on here. 3 to the negative third, n to the negative second, m cubed, all over k to the 0. Okay, the first thing I notice here is k to the 0 power. K to the 0 power is basically the same thing as 1. All of this is over 1. So I could rewrite this as just 3 to the negative third, n to the negative second, m cubed. Now it's my job to simplify it. Okay? So the first thing I see here is 3 to the negative third. That's a negative exponent. It's got to move to the denominator and become positive. Second piece I see here is n to the negative second, negative exponent. Got to move. Third thing I see is m cubed. That can stay where it's at. It's a positive exponent. So after I move everything, the m cubed is the only thing that stayed on top. 3 to the negative third moves to the bottom, becomes 3 to the third. And then n to the negative second moves to the bottom, becomes n squared. If you simplify this a little bit, it should be m cubed over 3 cubed is equal to 27 n squared. Is my final simplified answer. Let's keep going. 5 times w to the 0 power r to the negative 6th over 3 to the negative 1 t squared. Okay, so the first thing I see here is this w 0. This thing is basically a 1. I don't really have to pay much attention to it. Move what you need to move, and then keep the things you're allowed to keep where they're at. Okay, 5 can stay, positive exponent. R to the negative 6 has got to move to the bottom. 3 to the negative first has to move to the top. T squared can stay where it's at. Okay, so my new numerator, the 3 to the negative first moved to the top, so it's a 3. And I also have that original 5, so I got 3 times 5 on top. R to the negative 6 moves to the bottom, becomes r to the 6th, and then t squared stays where it's at. Simplify this a little bit. 3 times 5 is equal to 15. R to the 6th, t squared on bottom. Okay, let's keep going. Last couple here, change to this blue. Okay, so this is the first time we have an instance where we have the same variable on both the top and on the bottom. So my piece of advice is try to simplify first before you start moving things. Okay, so what do I mean by that? The first term I see here is I see 75 and 15. 75 over 15. Okay, and if I asked you to simplify that expression, just 75 over 15, all you have to do is you basically take, okay, ask yourself, how many times is 75 going to 15? Or 15 going to 75? If you take 75 and divide it by 15, you should get exactly 5. So 75 divided by 15 just becomes a 5 in the numerator. Okay, the next piece I see is p to the 3rd over p to the 5th. Okay, same variables, division in between, so we subtract the exponents. This should be the same thing as p to the negative 2nd, or what is ultimately 1 over p squared. P squared should be in the denominator. Okay, next piece I look at my m. This gold. We've got m to the 5th over m to the negative 4th. Division, same base. Subtract the exponents. 5 minus negative 4 should become 5 plus 4. It should be m to the 9th power. Positive exponent stays on top. M to the 9th on top. And then the last piece I see, okay, I see r to the negative 8 in the denominator. So it's basically the same thing as this. 1 over r to the negative 8. The negative 8 has to move the numerator. It should become positive r to the 8th in the numerator. Add it as such. This should be my final answer. 5 m to the 9th, r to the 8th, all over p squared. Okay, last one's pretty ugly. Let's see what we can do here. So I've got 4 to the 0, c squared, d cubed, f, all over 2c to the negative 4th, d to the negative 5th. All right, so let's see if we can take this thing apart and pull it into pieces. Okay, so the first term I see here, let's look just at the numbers. I see 4 to the 0 power over 2. 4 to the 0 over 2. I'll draw a line here. Okay, so I know that 4 to the 0 is the same thing as just 1. So when I simplify the numbers, it just becomes 1 over 2. Okay, that's my first piece. Second piece I see here is I see c squared over c to the negative 4th. Okay, same variables, division in between, subtract the exponents. This should be the same thing as c to the 2 minus negative 4, which becomes plus 4, which becomes c to the 6th power. Positive exponent stays in the numerator, c to the 6th. Okay, then I see d to the 3rd over d to the negative 5th. Let's change the color real quick. D to the 3rd over d to the negative 5th. Same base, division in between, subtract the exponents. d to the 3 minus negative 5 becomes plus 5, should become d to the 8th, d to the 8th in the numerator. And then the last piece I see, let's go with this red, we've got just plain old f in the numerator, so that's going to stay in the numerator. Okay, but the tricky part here is that every single piece in here is being raised to the negative third power. We can't forget about this guy that we got to do last. So when we clean this up, what is this going to look like? I'm going to erase this one because it's a little bit unnecessary. Don't forget about this 2. Okay, this entire quantity is being raised to the negative third. So what we have to do now is we have to distribute this negative 3 to every single piece inside of here. Goes to the C, it goes to the D, to the F, as well as the 2 in the denominator. Okay, so whenever we have a power raised to a power, we multiply the exponents. Okay, so when we clean this up, here's what it should look like. C to the 6th raised to the negative third should be C to the negative 18th. D to the 8th raised to the negative third should be D to the negative 24th. And that should be f to the negative third. And then in my denominator, it's going to be 2 to the negative third power. Okay, we're super, super close. Now we just got to make sure we clean everything up one last time. Change this nice blue. Okay, so in my denominator, let's just ask ourselves, what's moving, what's staying? All of these are negative exponents, so all of them have to move to the denominator. And down here, this guy's to move up to the numerator. So I'm running out of space here a little bit, but what should we be left with? So because 2 to the negative third started in the denominator, it moves to the numerator, it becomes 2 to the positive third in the numerator, then everything else moves to the denominator. C to the negative 18th becomes C to the 18th in the denominator, D to the positive 24th, then F to the third. Okay, so one last step here. If we have 2 to the third power, that's the exact same thing as 8. And then pretty much everything else stays the exact same in the denominator. C to the 18th, D to the 24th, F to the third.